You walk into a room, flip a switch, and the lights come on. It is an everyday action we rarely think twice about, but that instant glow has a physical starting line. The electricity powering your bulb is often generated miles away, burning inside the massive furnace of a coal-fired power plant. These facilities operate on a staggering scale, pumping thousands of tons of thick exhaust into the sky every single day. To understand what is actually in that exhaust, we have to look closely at the fuel. Coal is basically the fossilized remains of ancient swamp plants. It is packed tightly with dense energy, but chemically it is a highly disorganized, messy rock. When you set that rock on fire, it releases intense heat. Those extreme flames force the coal to violently react with the surrounding air, cooking up a chaotic mixture of invisible byproducts. So let's freeze that smoke cloud right in midair. If we unpack this cloud piece by piece, we can isolate and identify the 4 distinct environmental threats hiding inside. Let's pull out the first piece, a gas called sulfur dioxide, or SO2. Deep underground, ancient sulfur was naturally trapped inside the coal. When the coal burns, that sulfur is set free and chemically locks onto oxygen molecules from the surrounding air. This newly formed gas is highly toxic. Once it floats up into the atmosphere, it mixes with the natural moisture in the clouds to form acid rain. When acidic water falls to Earth, it strips the life out of entire ecosystems, leaving behind dead gray trunks where healthy forests used to grow. Because coal contains significantly more trapped sulfur than oil or natural gas, burning it drives the vast majority of this specific ecological damage. Next is nitrogen oxides, or NOx. The power plant furnace burns so hot it cooks the surrounding air, forcing nitrogen and oxygen molecules to fuse. Additionally, the solid coal releases its own locked-in nitrogen directly into the fire. When these nitrogen oxides hit the sunlight over our cities, they undergo a reaction that forms a thick, suffocating layer of photochemical smog. Generated from both the solid rock and the air feeding the flames, this double threat is a persistent hazard for urban air quality. That brings us to the third component, particulate matter. Unlike purified liquids or gases, coal is dug out of the earth as a solid rock. It contains a high volume of inorganic dirt, clay, and minerals that simply cannot burn. As the carbon burns, these rigid minerals undergo violent microexplosions, shattering into thousands of microscopic, jagged ash particles that fly up the chimney. Because these physical dust particles are so small, they bypass our body's natural defenses. They are inhaled deep into human lungs, leading to severe, long-term respiratory issues. Burning a solid, mineral-rich rock naturally generates a massive volume of this physical dust compared to cleaner liquid or gas fuels. Finally, we have to look at the fourth remaining pollutant, carbon dioxide, or CO2. Here, we run into a basic chemical reality. Carbon is the main ingredient that gives coal its dense energy. You just cannot burn carbon for heat without creating CO2. Unlike other pollutants, CO2 doesn't poison your lungs directly. Instead, it accumulates high in the atmosphere, trapping the sun's heat and steadily warming the globe. This animated chart compares the emissions of 3 identical light bulbs powered by different fossil fuels. To keep its bulb lit, the coal source requires vastly more CO2 output than oil or natural gas to produce the exact same amount of energy. The very chemical element that makes coal such a powerful source of electricity is the exact same element driving long-term climate change. Looking at our fully unboxed cloud, we have sulfur dioxide, nitrogen oxides, particulate matter, and carbon dioxide, all pouring from a single chemical reaction. Now, let's unfreeze the stack. Watching that white smoke billow into the sky carries a completely different weight when you know the exact anatomy of what is hiding inside it. For over a century, coal was the engine of human progress. It powered the heavy factories and lit up the expanding cities that built the modern industrial world. We traded cheap, dense electricity for a chemical recipe that degrades our forests, chokes our cities, and warms our planet. Understanding the invisible mechanics of this pollution lays the facts bare. It shows us exactly why the global effort to replace coal with cleaner alternatives is an absolute, unavoidable necessity.